What's up, guys? I'm Daniel Gerke with LeadLock.ai, and today I will be telling you about my context engineering method that I utilize within Claude Code to deliver excellent results. So as we know, agentic coding assistants need context. It's the bread and butter. And to balance what context you provide them and when, and not overload them with context, is really like surfing a wave. It's like learning to play a new instrument. It's a skill you only really get with practice. However, what I'm about to show you is definitely going to shortcut the process to obtain this skill. Okay? So who is this for? This is for anybody who wants to code. So solo developers, small teams, whoever. Okay? So the Forge pipeline works like this. You have find, outline, review, run, and then guard. And then it evolves. It's a continuous learning loop. And I'll show you exactly how it works. So find, say you have an idea. The first thing you should do is you should just have a casual, I call it vibe prompting session with your AI coding assistant, and just kind of shoot some ideas off of each other, get it to give you some recommendations, and come up with a nice kind of idea, like a rough idea. Then with that idea, what you need to do is use the first part, which is called find. And these are just slash commands. So you have the find slash command that takes in the argument, which is the idea you just had. What happens after that is it deploys 4 different sub agents. Why? Because sub agents should be used anytime you have to do external research or that otherwise would eat at the context window of your current chat. So for example, when you deploy these, in the current chat window, you're only going to probably consume 8,000 tokens, 8 to 10,000 tokens, but each one of these is going to consume like 70, 80, 90,000 tokens. So it works like that. That's why you want to do the 4 different agents. It just works a lot better. And this diagram, by the way, was built with the slash command in Claude Code. Like, I didn't draw a single thing of this. This is an Excalidraw diagram. So if you want that, just let me know. I can give it to you. But it's super easy to make, really. You just go on Claude Code and say, make me a slash command that makes Excalidraw diagrams, and it'll just do it. But anyway, or you can use the Forge method to do it, right? But Forge is a little overkill for this. So then, once you have this document, which is your initial brainstorm, that becomes a variable, basically the argument, to put into the next part, right? Which is outline. So you transform your brainstorm into a foolproof, step-by-step implementation blueprint, okay? That will create a spec.md file, the spec file, right? And this is what all goes into the spec file. So when you run when you run Forge outline, this is a variable, brainstorm is a variable, yes, but brainstorm also has references in it to these documents. So it's true like context packing. It's using its context wisely. So for example, in outline, if it needs to dive into something, it can dive into brainstorm. Brainstorm almost acts like an index to other files. That way the context stays efficient. And that's what you want. Now, after the spec sheet is rolled out, and this is what a spec sheet has: goals, files to create, files to modify, database changes, step-by-step instructions, gotchas and preventions, rollback plan, which, by the way, it also, when creating this, it actually takes it from the learnings. So we have a learnings folder we'll get to in a second, but anyway. So it makes a continuous loop and just gets better and better, okay? So once we do that, we review it. So we review it with 4 different subagents. We review the spec with 4 different subagents, testing for different things, completeness check. And it does a mock dry run. It imagines if it's all done, how is it going to work? Is the code going to break? It decides if it's simple. Is it overly complex, or is it good to go with simplicity's sake? And then it also verifies that the gotchas are in there and there's none that are missing. So then you approve that, and each one of these you're just kind of handing the baton off, right? And this is where you finally execute. You finally run the spec. You finally tell your coding assistant to execute all of the task details within that spec file, right? So you execute the spec step by step with intelligent pausing, helper spawning, and continuous learning, right? So you follow the spec, you validate each step, you pause when uncertain, and then if it's uncertain, it'll just ask you. It's programmed to just stop and ask. And then it has helper sub-agents it can deploy as well, which learnings lookup, so it can look up past bugs, the documentation lookup. We generally have a research folder with all the documentation in there. Pattern finder, test writer as well. And we have bug fix, got you found, new pattern, API insight. That goes into the learnings, right? Once that's all done, then we have guard, which is the final or second to final part of the Forge methodology. And that checks for everything. It verifies everything. Lint and format, type check, unit and integration, E2E, like playwright tests, and success criteria. Then you have a verification file, which shows all of the tests passing, and then things that you should check as well manually to verify. Okay? Then after that, really during this, it updates each time when you're debugging or whatever, it updates the learnings folder with things that it learned, common gotchas and stuff like that. So the next time you do a feature, you build a feature, and you start off with the find command, it looks into the learnings folder, takes that stuff out, right? It takes that stuff out and puts it in here. So it's a continuous loop. It gets smarter and smarter each time. Guys, if you want any more videos on this method, the Forge method, let me know. It was a pleasure speaking about it. Have a good day.